Algebraic expressions are made up of numbers and mathematical operations. Numbers come in two types, constants and variables. Constants are numbers that don't change in value. Numbers like 7, 1/2, 2 46/100, and -3 are all constants. Variables are numbers that can vary or change in value. In algebra, x, y, and z are the most commonly used letters for variables. Operations are the actions you do to constants and variables. Addition and subtraction are operations. Some other common operations are multiplication, division, and taking roots. When letters like A, B, and C are used, they generally represent constants. In this expression, A, B, and C are constants, while x is a variable. The two plus signs show that the only operation used here is addition. While there are many ways to combine constants and variables, only certain combinations are polynomials. Here are the basic rules. The first rule says that to be a polynomial, no variables appear in denominators. To check this condition, find the fractions in the expression. If you see a variable like x, y, or z in a denominator, the expression is not a polynomial. 6x divided by 13 is a polynomial because x is in the numerator. But 6 divided by x is not a polynomial because x is in the denominator. The second rule states that an exponent on a variable is a positive integer, like 1, 2, 3, 4, and so on. In the first expression, 3 and 2 are positive integers, so this is a polynomial. If the exponent is a negative number, a fraction, or a variable, the expression is not a polynomial. Once we've taken care of the exponents, Rule 3 says that the only operations being performed on a variable are addition, subtraction, multiplication, and division. Let's look at some examples. This one should be simplified, but yes, it is a polynomial. Here's another. There are no variables in denominators, but notice that the exponent is a fraction. This one is not a polynomial. In this expression, notice that the last term has a variable for an exponent instead of a positive integer. This one fails too. P of x is just a nickname for this third-degree polynomial. To determine its value when x equals 2, substitute the number 2 for each x and simplify. P of 2 equals 32. We can use any capital letter for a polynomial's nickname. Here are two, P of x and Q of x. Once we have evaluated these polynomials, it's easy to find their sum.